Going on now to topic 1.5, we're going to be dealing with exponents and radicals. Again, this is a review of some basic algebra. Now, when we are dividing in this form of fractions here, and we're going to simplify, what's the rule? Well, the rule is we take the exponent from our denominator, usually, bring it up across this division bar, and when we get to the numerator, the sign, which here is positive, it becomes negative, and we just subtract. Remember, when we multiply, we're going to add exponents, so when we divide, we subtract exponents. Now here they're introducing the product to a power. So here, keep in mind there is a little 1 right there and a 1 right there. This is an unwritten exponent when there isn't one present. There is a 1 there. So when we have the exponent outside the parenthesis, we are just multiplying. So it'll be a to the first times n, which makes it a to the n, and b to the first times n, which makes it b to the nth as well. Now, of course, knowing with examples that you'll be getting in practice and quiz me, that's where you know if you apply these correctly. So again, there is a 1 there and a 1 there. So we're going to multiply. A to the first times n gives you this. B to the first times n gives you this. So these are some of the basic rules. Now, negative exponents. Now the rule is, and we mentioned it briefly just a few moments ago, and keep in mind every number is over 1, even though it's not written, that as we take a negative exponent and bring it across this division bar, the sign of the exponent changes and it becomes positive. So these two terms are equivalent. 1 over a to the nth becomes a to the negative nth over 1. And again, you'll have practice. Now, another interesting thing to note is when you have a fraction and it's to the negative power, if you take the reciprocal of what's in here, just flip it, the exponent then becomes positive. So once again, it's called the inversion property. If you have a fraction that's to the negative exponent, to get it to the positive exponent, just flip, that is, take the reciprocal of this by flipping, and then the exponent becomes positive. A good little technique to remember. Okay, now they're asking us to do some of these and to simplify. So in this first one, this is going to be 5 halves. Now instead of being a negative 3, all right, since we took the reciprocal of this, this will be a positive 3, which then becomes 5 to the third 2 to the third. And then if we expand that, that's 125. And this is 8. And this would be, again, x over 3 to the 5th power. So that's going to become x to the 5th, and then 3 to the 5th. X to the 5th stays the same. And I use my calculator. 3 to the 5th is 243. There's our solution A, and there's our solution B. Now, let's see what they want us to do here. All right, hopefully they're going to give us some examples here. Okay, well, I think what they're asking here, they have a couple of things going on. If you have an exponent that's in a fractional form, this is called a fractional exponent, or exponential fractions. The exponents are fractions. Remember, this is still the base. This is the exponent. Now, if it's in exponential fractional form, this can be converted to a radical form. We put the radical sign. Our base, A, becomes the radicand. That's what goes under the radical sign. Now the n that's found as the denominator of the fraction becomes our index number here. And the numerator becomes the exponent on the radicand. So this is exponential fraction form. This is radical form. They relate to each other. And I think what they were showing us before, if this number n here is a even number, 2, 4, 6, 8, then you cannot have a negative radicand if that's an even index number. If it's an, because then that's not a real number. But if this index number is odd, such as 3, 5, 7, then it's okay to have a negative radicand. Okay? And hopefully that's what they're asking you to look at here. Maybe they'll give us some examples. Okay, here's a little summary then of what we've been talking about. And again, a good thing to have in your notes and to study. And as you do your practice and examples, be able to work them out. So maybe this is what I've shown you already. It looks like it. Now, reading the textbook is a good idea too. This is just a little quick summary here. And this is what I showed you. Now, another place to put the exponent of the radicand is outside right there. This is inside, this is outside. I don't like when they put the fraction in this form. I like my fractions with a horizontal bar, so I could really distinguish what's in the numerator, what's in the denominator. Remember, it's the denominator that is our index number. The numerator is our exponent of the radicand. Now, if you had, and let me give you some background of this here. If you had the square root of, let's say, 49, the square root of 49 we know is 7, but it also could be a negative 7. So since there are two possibilities here, whenever n is an even number, they're suggesting the best way to show the answer is to put it in the absolute value. So that could have been a negative, because the absolute value of a negative 7 is 7. So that's just another way to show you this. If n is odd, then that's fine, because having an odd index number there, this value can be negative without a problem. And again, they're not showing you a lot of examples. I like examples, that way you get to see. So we could have a negative 8 here if this is the third root. You could also have a positive 8. Well, the third root of 8 is 2, and the third root of negative 8 is a negative 2. So if you multiply negative 2 by itself 3 times, you get a negative 8. I believe that's what they're showing you here. Okay, now when we are working with radicals and our index numbers are the same, we could just multiply the radicands and put it under a common radical sign. So this is legitimate, and that's how it's done. And the fractions work exactly the same, keeping in mind that b over here cannot be a 0, because that would make it undefined. Okay, we're going to go right on to section 6. Okay, going on now to topic 1.6. They're going to give us a full review of equations that are to the first degree. That is, the exponent on the letter is only 1. So some general principles in solving equations. And here they're saying if you have, and let me show you this in diagrammatic form. Now, the whole nature to an equation is if you had a balance, and on this side you had, let's say, 5 pounds of something, and on this side you had 5 pounds of something, they would balance. So this is sort of saying that both sides are equal. Now, if I added another little bit to this side, it wouldn't be equal anymore, and it would tilt. But if I added the same amount to this side, they would still be balanced. And in the same way, if I took away some from each side, let's say I took this much away and this much away from each side, it would still be balanced. Now keep in mind, as I add something to both sides, it's not the same amount anymore, but the key is it's still balanced. So as you work through the process of solving an equation, you're going to be adding things to both sides, subtracting things from both sides, multiplying both sides by something, dividing both sides by something, until eventually on one side you get an x, and on the other side you get a value, 5. Now this process of solving an equation is the skills they're going over here. So they're saying we can add something to both sides, or we can subtract something from both sides. It's still equal, okay? We can multiply both sides by something. It's still equal. It's not the same, but equivalent. That's what they're showing you here. So, again, they're not starting you off with baby things. This is an advanced course. Let's see what they want us to do here. So we have parentheses. So one of the things we have to do is clear parentheses. So this becomes 2k plus 3k, distribute, and this becomes a negative 12. And this becomes 2k minus 6. Now, over on this side, we have like terms that we're going to group together. This becomes 5k minus 12 equals 2k minus 6. And this is sort of a general intermediate step that you're going to have. That is, you have a variable, a term, a constant, a variable, a constant. Now we want to get all the variables on one side. So I'm going to subtract 2k from this side. I'm going to subtract 2k from this side. Now this side becomes 3k minus 12 equals a negative 6. Here the k's cancel out. I'm left with a 0. Now I want to get this to this side, so I'm going to add 12, add 12. So I get then 3k equals 6. Now to get the k by itself, I'm going to divide both sides by the number that's with the k, because this is 3 times k, so I'm going to divide it by 3. Divide this by 3. Now I get a 1k, which I don't write the 1, and I get k equals 2. Well, these steps in sequential order are the steps of solving an equation. And you see what we've done is we kept modifying that equation little by little until we get to the point where k is equal to something. Okay? I'm not quite sure what this is. Oh, I see. Here they're saying if you had a 3r equals 1, you would just divide by 3. And then that would be r is 1/3. Here you're dividing by 2 to isolate the r. R is a negative. I'm not sure what they did there. So that should be a negative 3/2. Again, I'm not sure what this is referring to here. It might be an error. I found one already on here, so let's go on. So they're telling us, maybe they'll show it to us here. Okay, a lot of stuff in there. I like it my way. Okay. Now, when you are asked to do a word problem, there is a series of steps you should follow. They're listed here. You read the problem carefully, look it over a couple of times, try to determine what the question is asking, then translate it from English into algebra, and then carefully solve the equation and see if your answer makes sense, and then give your answer statement. Again, looking at your textbook I'm sure they have all of this there, and it will be useful. Okay, we're going right into section 1.7, our last section of chapter 1, and this is on the quadratic equations. Now here we're going to have an equation that's perhaps to the second power, or in some cases even to the third power. So let's go on. Now for this we're going to use what is called the zero factor property. That in order for this statement to be true, A, B equals 0, then either A is 0 or B is 0, or they both are 0. This is called the zero factor property. So here's an equation that's quadratic. It's r to the second. So step one in solving equations here is to put it in what we call standard form. It's going to be 6r squared plus 7r. Bring the 3 to the other side through transposition, and we equal it to 0. This is now a quadratic equation in standard form. Next step, factor this. Now we did a little bit of factoring earlier. So what is this going to be here? I'm going to have to pause it to figure this out. Oh, it didn't take me too long. I had to find out factors of 6 that will lead me to this up here. So I figured it was a 3 and a 2, and I'm going to have a 3 and a 1 here for this. So when I do my outers, that's 9. When I do my inners, that's 2, and the difference will be a 7. So I need a positive 9 and a negative 2 to add up, and if I FOIL this, it now gives me that. Again, there's a lot of math going on here. Now the next step is you take each of the factors. Remember we said A, B equals 0. So we're going to take this and treat it as if it were an A. So that would be 3r minus 1 equals 0, or 2r plus 3 equals 0. So I transpose the negative 1. It becomes a positive 1. I divide both sides then by 3. X equals a positive 1/3. I think this is what was on the other page here. So I think that's a technical glitch in the program. Yeah, that makes sense. This is going to be a negative 2. And then divide it by, I'm sorry, how about a negative 3? Bringing this over, divide it by 2. Yeah, that's where this came from. That thing that was on the other page. Okay. And these are my solutions. And if I put this in there and this in there, they both work. And that's what they're doing. And there it is. So this was a repeat there from something. Okay. All right, now we have what is called the square root property. Again, lots of stuff going on here. If you have x squared equals b, and I want to solve that equation, the square root property says I can take the square root of this side, and the square root of x squared is x, but in order to take the square root of the other side, I have to go plus or minus the square root of b, so that I ensure that I get two possible answers. So x then is equal to plus the square root of b minus the square root of b. Usually you have to write them separately, but the key is you get a plus or minus when you take the square root of a variable. Now, here is the standard form of the quadratic equation. If I solve this for the letter x in there, I get what is called the quadratic formula, where if I can identify my a term, my b term, and my c term, it has to be in standard form. Put that value of a there and there, the value of b there and there, and the value of c right there. I can grind it out and end up with my solutions. If something doesn't factor, this is a multi-purpose way of solving these equations. Now, another thing too is that in the quadratic formula, under the radical sign, you have a negative, I should say you have b squared, it's not negative, minus 4ac. This is what's under the radical sign. And then over here you have a negative b. That's where you have the negative b. And this is all over 2a. Now this part that's under the radical sign, they call that the discriminant. Now the discriminant determines what kind of answers you're going to have when you use the quadratic formula. For instance, if this is 0, then you're only going to get one real solution. If this is a negative number under here, remember we said you couldn't have a negative under the radical, but if it comes out as a negative, then there's not going to be any real solutions. That's this one right here. There are no real solutions. If this comes out to be a positive, then there are two real solutions. So they're saying if the discriminant is greater than 0, two real solutions. If it's equal to 0, one real solution. And if it's less than 0, that is it's negative, no real solutions. And that's what they want you to pick up here from the discriminant. Okay, Pythagorean theorem, a quick review. Pythagoras was a Greek that he said if this side, and I'll just give you some figures here, if this side were, let's say, 3 units long, and this side were 4 units long, and then this side was 5 units long, watch what happens if we square this. Square this. Well, this is going to be a 9. This is going to be a 16 down here. And this is going to be a 25. So if we square the legs of a right triangle, they equal the square of the side opposite the right triangle, the right angle, which is the hypotenuse over here. And the formula, general formula, is a squared plus b squared equals c squared. So I'm imagining that you're going to be doing some of those problems. And that will wind up your Chapter 1 quick review.